All right, have a seat. Have a seat. So, I'm gonna do like the first one, or I'm gonna do like three total. I think I'm gonna do the first two. So these are all yours, and I'm gonna do this one, and let's see if you can get these. If you can't, it's fine. So I'm gonna do this one with you. See if that'll help you to get these. I want you to try these. If you can't figure them out, I mean that's fine, because we're gonna do this more next week. But give it a try. Okay, you definitely have to have these done for homework. Okay, so for this assignment, it's going to be very beneficial for you to have a periodic table like this. You could also just look this up online. So for this one, lithium, it is right here. It's in period 2, so we know it has 2 rings. I'm sorry. So I'm just going to put a dot there. So 1, and there's 2. So we know we have 1 electron, 2 electron. So, and then we have 1 more right there. So that's going to be our Bohr model for lithium. Our Lewis dot structure for this one, well, we just write the symbol, so Li. And, well, we only have 1 valence, and also we know that from our column here, so let's put a dot. There we go. That would be the first one. All right, magnesium, a little bit harder, I guess you could say. So for that one, we're in 1, 2, 3, 4. So we have 4 rings. Give myself some space here. 1, 2, 3. Oh, yeah, that's not good. Okay. Still, it's fine. All right, so we know we have 2, because that's this row. Next we have 8, so we want to get to 25, but it's 4, another 4, that's 8. I'm just filling in our gaps here. Makes the most sense. That would probably be the most stable. There's 8 again. Okay, so we would be, what, right here? So we have 1, 2, 3, 4, 5, 6, 7. It was very lopsided, but that's okay. All right, so now our Lewis would be, oh, I'm doing manganese, aren't I? Well, that's fine. I'm going to stick with it now at this point. So I know that said magnesium and I did manganese, but still, I think you get the point. Okay. So now let's do this one. Okay? So here it says draw the Lewis dot structure for the following compounds. It says remember bonding and the octet rule. So for us, the octet rule, you know, they want at least 8 electrons to be happy. The only exception to that rule is going to be helium and then hydrogen 2, because they only need 2. So they only want 2 electrons to be happy. Okay, so those are the only 2. So H/helium only want 2. Only want 2 electrons. Okay, so there is some more exceptions to that rule, but for now, that's all we need to worry about. And then for this, we'll have 1 bond is going to equal 2 electrons. So 1 bond is going to equal 2 electrons. Well, first let's draw our Lewis structure of these. So that is going to be hydrogen. Well, that's just going to have 1, right? Put that there. And then chlorine, how much does chlorine have? Well, that's going to be 7. So 1, 2, 3, 4, 5, 6, 7. You might notice how I set that up cleverly, right? So looking at this and looking at these rules, what can we do? Well, these two can bond, and we would get and let's see. Hydrogen would have 2, right? So that's good. Chlorine would then have 8 because we have 2, 4, 6, and then this one counts as 2. So we'd have 8. And what's kind of funky is this bond is going to count as 2 for both this one and this one. We will get into why that actually is later in the week, okay? But for now, that is your homework, is these, and then try to do these two.